Hello, welcome back to COG 376. Last time we talked all about what it means to work with text in the context of trying to make language models on a computer, right? So today I want to translate that from working with text to programming with strings. You can consider this a first step into playing around with Python. We're just going to do it live here. So this is a little less lecture-y and a little more demo-y, but yeah, I suggest you follow along. I'll show you right now how we can do that. In the future, we'll probably want you to install your own version of Python or make sure you know how your existing version works, all that stuff. But for now, we're going to use a website that is, it has a Python interpreter in it, so we can play around in there. So, one sec. New window. And we will, shrink it down. Okay. So I'm going to open, I have a bunch of notes here. You'll be able to follow along with those, and I will post them later, similar to the way I would post a lecture PDF. So I'm going to open them in my favorite editor. I use Atom. Oh, come on, Atom. Hang on. I gotta go back. So I think I need to make a new Atom window first, because that's the way it does. Here it is. Okay. We don't need to fuss with the project. We'll just drop Atom in there. So, not Atom, into Atom. All right, that's my file. We don't need to fuss with that anymore. Okay, in the world that we're going to be working in, I'm pulling stuff off of a text file, but you just have to click along in the interpreter, the Python interpreter we're going to pull up on the side here. Let me grab it. I'm using this online one at the actual python.org website, for stability's sake. Don't want this to become too outdated. It loads up. It might take you a second when you're first loading it, but here it is. This is a Python command line. We can type numbers into it and it returns them. Okay, cool. Okay, so let's talk a little bit. Make sure I'm getting audio here. Okay. So normally if I was going to introduce anyone to programming, I would try to stick to something a little more visual. Python Turtle has a really cool way of learning to paint using Python commands, Python instructions, and it's rather than just boring old lines of text. But because the focus of this class is text and language that's encoded in text, we're just going to jump in with those specific things that are going to matter, and hopefully, because of the context of the course, you'll be able to attach them to something that you find interesting, as opposed to just, oh man, why are we doing all these letters and A's and B's and stuff? So I'm also going to give you a taste of a lot of the fundamentals of programming along the way. I'll make sure to highlight them as, hey, this one is actually one of the most important things about programming. So a lot of them that we'll touch on today are, but just so you know, this is a pretty broad, even though it's a very simple example we're going to be working through, pretty broadly it covers a lot of the main things you need to know about programming. Okay? So dispel all the fear that you might have if you're walking in for the first time, and come along with me if you're an old hand at programming. Just get back up to speed. So here's the thing. You can go to this link, console.python.org/python.org console, or python-dot-org- whatever. You'll go there, and it opens up a Python interpreter for you. This can actually take lines of Python code and run them right there. In the future, we'll get more into the guts of doing it in a more a stronger way, but for now, we can just play around in here. You can just play around in here. You can open this anytime you want and screw around with Python code to see what it does and how it works. So let's just walk into the concept of programming fresh, okay? What are we writing? We're writing instructions. So instructions are lines of code. Lines of code are instructions, okay? Keep that in mind. It's easy to look at lines of code and think, oh my God, someone's declaring this is algebra, is this calculus. It's not. Every single line is an instruction to the computer of something you want it to do. Here's the classic. The first instruction you usually use in these things is, hey computer, print the words hello world for me. This is the universal handshake, some call it. It shows that the system is accepting our input and giving us output that we know what the answer is, right? We know it should be displaying this text. So to do that in Python, we start with a print statement. It's a system function that takes one argument or more. It can take several. And the argument is, what should I print? And what we want to print is the string hello world. So how do we do that? Print, quote, hello world. Now before we fire, let's look at this. Print is the function. It is the print statement, and it opens parentheses so that you know what you're handing it. You're saying, hey, print function, here's a string, use it, right? So we're giving it hello world, and if we hit return, it has printed hello world. Ah, that's neat. Great. That's the basic. That's the very first thing you do with a programming language to make sure you and it are on the same page, right? So that's printing hello world. Now, let's walk into variables. So this is another, honestly, a lot of you who have already done some programming, you're like, variables are the simplest thing. These can be a sticking point. It's weird to think about this, and you don't typically see equal signs as meaning anything other than, oh, the x and y and the values of these different halves of the equation must be balanced. No, this is another instruction. So variables are essentially the idea that this is a labeled bucket where we can store information. In fact, I'm going to carried return that and comment it out. Also, you're not going to want to run this script. This is really just a place to put it. Well, don't think about that. This is just text to you for now, all of this. So, but a variable is a labeled bucket where we can store something, anything, information of any kind, right? So declaring and assigning values to variables, that is an instruction. So let's declare the variable thingy. Thingy equals the string hello world. Oop, get the exclamation point. All right, that happened. Nothing was returned, because when you assign something, nothing is returned. But if we want to look at what's in there, we can just type thingy again. So this is an instruction to the system to say, return whatever comes out of that bucket, the bucket labeled thingy. Aha, it contains the string hello world. Okay, that's a good start. So anytime you want to know what's in one of your variables, you can just type it straight in to the interpreter and you can find out pretty quick. Now, on the other hand, that's just sort of a nice thing because it happens to be the case that when you throw in a variable, the console will just kind of spit out whatever the thing returned was. Sometimes we want to be more explicit and say, hey, print this specific thing. So if we call print again, we say print thingy, right? What's going to happen? Hello world. Same as before. The print statement takes the contents of the thingy and then does the printing. You'll notice there's a slight difference here. So when I returned thingy, it actually came back as a string, like in terms of it's between two quotes. Whereas when I printed it, the system, it skips that. It just says, I'm going to print these exact letters. Okay. So that's the concept of a variable. You can put something in it, and from then on, you can refer to that by name. You can also change what's in it. So if I want to change it to a little more, let's get a little more interesting sentence than hello world, right? Thingy equals the quick brown fox jumped over the lazy dog. I could just copy paste this, but I want to show you, first of all, that I make typos just like you will, and also that this is all from scratch every time. You can always do it from scratch. What's in thingy now? If I say, hey system, print thingy, The quick brown fox jumped over the lazy dog. Woo! Okay, that works. That seems good. Okay, so that's the idea of variables. Let's take a quick aside and talk about how these systems work with numbers, though. We're kind of working with a kind of complicated object, honestly, when we're using strings. Let's go back to the basics. So, what happens if I just put the number 5 in here? The system knows that that's a number, and it's going to return it as the number 5. Okay, how about 10? Okay, cool. So, Python knows numbers. What about 5 plus 10? Oop, I hit enter twice. 15. Okay, so it actually knows how to do the math with them. And so 5 times 10 divided by 1,000, oh, shoot. Hey, we're getting there. It can even go into fractions. Whoa, great. So numbers work cleanly inside of Python and any programming language, of course. But this is something to know, right? These aren't strings. These aren't complex, big, long chains of letters. They're just numerical values. These are also in your purview. So we can also store these in variables. So let's do num1 equals 5, num2 equals 10. Okay. What's in num1? 5. What's in num2? 10. Nice. What's in num1 plus num2? Because these are numbers, the system will say, okay, I'm going to pull that number out, pull that other number out, slam them together, you get 15. Aha. Okay. So, and remember that we can reassign these at any time. So we'll say num1 equals, now here's a tricky thing. You can actually use the current value of num1 to put something new inside of num1, right? So we're going to do that. Hang on to your butts. So here's what's going on. The system gets this instruction. It says, okay, you want me to put something in, hang on, I'm trying to stop highlighting. Okay, you want me to put something in the variable labeled num1. I'm going to do that at the end of this. So that's what the equal sign is saying. Assign something new to this on the left. From here on, we have, okay, well, what's currently in num1? Well, that's going to be what? 5. And then what's currently in num2? That's going to be 10. So this will get, num1 will contain 15. Let's see. Aha! Now, if you ran that same statement again, it would go up again, right? We don't need to do that, though. An important point here is that the way we deal with variables and the way we deal with numbers and such, it's all instructions. You are telling it, take these things on the right and put them in the thing on the left. So that if it's not an algebra equation, it's not some like declaration of num1 shall always be equal to num1 plus num2. That would be a ridiculous statement. So let's change num2 just to show this. Num2 is 1,000 now. Okay? If I look at num2, it's 1,000. Num1 is still 15 because that happened. The instruction happened. It's forgotten. It's gone. It's lost to the wind, right? So when you do one of these declaration statements, you're saying, take the right, put it in the left, forget the rest, and move on with your life. So I hope that helps to anchor in place the idea that any variable you have, it's only ever going to get filled with something new when you tell it to. That's an instruction, just like everything we do. So let's do some more things. Real quick, just to show you another data type that's important is Boolean data types. So I'll just type them in first. True is a value. It's not just returning a word. It'll blow up if you type something that doesn't make sense to it. So true is a value. So is false. They have to be capitalized to make sure if you ever have to use them, right? So Boolean values are just binary values, true or false. They're really useful for doing things like conditionals, which we'll get into in a little bit. And they help you to decide, like, okay, what should I do and when? When some statement is true, I'll do something. And when some statement is false, I'll do something else. So that's the idea here. Scusi. And just to show you also that, so there's Boolean values, there's numerical values, and there's also strings. So let's get back to strings. Let's remind ourselves what's actually in thingy. Print thingy. The quick brown fox jumped over the lazy dog. Great. So this is the string that we put in there earlier, and it's still there. Ha, fancy that. So this variable contains a string of text. Strings are actually objects. So this is a new concept. In fact, I'm going to write that down. Strings as objects. Objects are more complicated than just single numbers. They have sets of operations, they have properties, blah, 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 blah. We'll walk through a few of them. So, okay, thingy is a variable and it contains a string of text. Strings are objects and they're more complex than simple numbers. So they have a lot of fun features that we can play around with. So first of all, let's talk about some functions that might need particular kinds of objects. For instance, length. So a function, just like the print statement we used, it's a group of hidden instructions that we can use in a particular way. They're written somewhere else, and we don't always know what's going on inside of a function, but we know what it should do, right? So some functions are meant to work only with certain kinds of objects. So in this case, length is meant to work only with objects that have lots of things in them, so that you can determine what a length means. So, for example, len is the function for getting length. It's going to return a number equal to the length of the string. So thingy has a string of, okay, let's do it. I'm going to do it annoyingly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Oh, I might have misclicked one. So we'll let the robot tell us. What's the len of thingy? 45. Okay, I didn't miss one. Fantastic. So this is a function that takes an object and says, I'm going to count the things in it. How many items are inside this object? If it was just a regular number, what's the len of the value 5? It blows up. That's fine. By the way, get used to typing things into the console, into the interpreter. It's okay to blow things up. You can always restart. You can always save your instructions in different places and blow it up. It's good to blow things up. So fail fast, fail loud, so you can learn, right? So okay, this is cool. We can check the length of the string. So there are 45 letters, or characters at least, in the string thingy. Okay, what else can we do with this fun object? Strings allow for indexing, so you can pull out individual characters from the string to look at them. You can do it by way of their address in the length of the string, in the string. So thingy sub 0 means give me the first thing. Yes, off by 1. This is 0 is the first number in these kinds of scenarios. Sorry, that's just the truth, and that's exactly how most computers will do it. I mean, all computers, but most languages will do starting from 0. You too shall learn to start from 0. So, what is the first character of thingy? Well, capital T, right? Great. Trying to get rid of my highlights. Okay, what about the 1th character, the next one? So the 0th, the 1th, so thingy sub 1, H. All right, cool. So we're seeing that we can index in and say which letter do we want, right? We can do thingy 2, thingy 3, etc. You're starting to get it. So we see THE space. Cool. Okay. We can also go backwards. This is just a nice quirk that isn't too hard to pick up. So you can go -1 to get the last character. Neat. What about thingy sub -2? The last letter should be a G, right? Quick brown fox jumped over the lazy dog. Yeah, cool. So that's just the idea that you can use numbers to pop into the string and pull things out. So what are some other things we can do with strings, as they are these nice complex objects? Well, one fun thing is a lot of objects, so we're talking kind of broadly here, a lot of objects will have functions attached to them that are called methods. Same idea. It's code that exists. It's hidden instructions that you can use and reuse in different ways. So strings have several methods that you should be interested in. So upper, this one's fun. It'll just turn them all to uppercase. So thingy dot upper. So dot says this, we're assuming this is an object, and we're going to go get its method upper, open paren, close paren. Look, the quick brown fox jumped over the lazy dog. This is a value that thingy dot upper returns so that we can use it, right? We can do thingy dot lower to make them all lowercase. We can do thingy dot title to make it title cased. Ah, that's nice. It can detect the start of a word and then it makes it uppercase. Great. These are methods of strings. So it's like custom code that works specifically on strings. It's very useful. We can also do index. So this is a way you can find where a letter lives in the string. So if you know the quick brown fox jumped over the lazy dog, oh, by the way, one note here is that thingy has not been changed by us calling these. It's still the original string. When you call these, they just return a version of that string that you can then take and save it somewhere and use it for something else, right? So thingy still has the original sentence in it. What if we want to know? We know that you may know that quick brown fox jumped over the lazy dog contains every English letter, right? So we know that if we search for something in this string, we can find it. So what if we do thingy.index? So this is going to say, give me the index, the first one you find, of the letter Q. Aha. So 4, 0. Hang on. 1, 2, 3, 4. That's correct. What about thingy.index of X? That's going to be way later. X happens partway through here, right? Whereas thingy.index of the period, I misspelled. You see thing.yindex, that's nothing. You can hit up in the interpreter and it'll take you back to the last thing you typed so you can correct it like a jag. So the 44th index contains the period. Because remember, the 0 is the first one. So it's the length of 45, etc. Okay, so this is neat. Now let's look at how you might use these things together. Okay, so let's save one of these values, right? We're using these interesting functions or these methods and saying, oh, they dump values out. That's neat. Well, what if I want to use the value? So let's say index 1 equals thingy.index of the letter Q, right? We're trying to save where in this string the letter Q appears. Okay, I done it. Let's look at it. What's in index 1? The number 4, just like before. Okay, now I can say, just like we did before, we can index based on numbers. So we can say thingy sub index 1. Aha, it's a Q, just like it promised, just like it found. That's neat. We've been able to take some numerical value that helps us know where something lives in the string, save it to a variable, and then reuse it right away. Cool. So that is a lot of the ways we can push through this string. And a lot of the features that are available to strings just sort of by default. We can make all our own stuff too, but it's good to know what the basics are that are available. So now let's take a step towards something that we did in the last lecture that we focused on. Tokenizing. Ooh, okay. So what if we want to split a string of text into units of meaning, right? In fact, I gotta remind us all, units of meaning. Bang, bang. So, all strings have a method called split. Split, by default, breaks a string up into smaller substrings that are also, they are still strings themselves. So don't think of substring as something special. It's just break them up into smaller strings by the empty spaces in it, by default. So, what happens if we do thingy.split? Whoa, what's going on? So, sorry, that I know what's going on, but maybe you are like, what? Why is it, what are these brackets? What's this deal? These are a bunch of strings. The quick brown fox jumped over the lazy dog. And they are contained within brackets and separated by commas and spaces, but those don't matter. This is a tokenized sentence. We have split it up into these little tokens. But what is this structure we're looking at here? It's called a list. Lists are the sort of the fundamental thing of how you can get collections of things set together in Python. So just in Python, lists are the basic way to say, store a whole bunch of stuff in this one object and or potentially variable, right? I can store an object in a variable, just like we did with strings. So in other languages, you might see this as this concept as arrays or array lists. Python just keeps it simple as lists. So just think of these as lists of things. They can be lists of words, which are text or strings. They can be lists of numbers. They can be lists of words and numbers. It doesn't matter. You can lay them out however you like. So let's split this up again, but actually save it, because again, thingy is still a sentence as a string. So let's save the result of splitting thingy up into something called wordies, a new variable name. So thingy.split. Okay, nothing happened, but what's in wordies? Yay, so this is our list. We have saved the list of text that has been split. Wonderful. So, wordies is now, it's a list object. And lists have a lot of things in common with strings. They are both collections when you think about it. So for example, you can look at each individual item. So in a string, each individual item is always going to be a character, a single letter, whereas in a list, it could be kind of anything, any other variable, right? Any other value. So let's index into wordies. Wordies sub 0. What should it be? The first word, right? The. All right. Wordies sub 1. It's going to be quick. Wordies sub 2. Blah, blah, blah. Wordies sub -1. Aha. Dog. Period. Great. We didn't remove the period. That's fine. We might do that in the future. Just keeping you on track here. So that's the idea. So in the same way that we can look at individual parts of a string, we can look at individual parts of a list. Okay, so you can also do the same index process where you search, right? You can say wordies dot give me the index of the word fox. Oops, Ford, fox. See, when you type and speak at the same time, your production system gets jumbled. So, wordies.index of fox. Where's the first time this value, this whole word, appears? At point 3. So 0, 1, 2, 3. Got it. How about wordies of index, or dot index of, what about forks? A word that doesn't exist in there. and it blowed up. That's okay. That works. It's okay for it to blow up. Sometimes you might need to fix it if it does, but don't worry about it. So that's how the index function is going to handle it. This is great. So now we're seeing that we can break a string up into a more complex object and start to work with it, do things with it. These chunked out, tokenized bits of text, right? So, okay, what if we want to do some things with it? Well, there's a lot of things you can do, and using what we've already talked about, you could do all kinds of stuff. Save it into different variables, chop it up different ways, capitalize it, lowercase it, move it around. There's a lot of things you can do with just those abilities. But I am sort of pushing us in a direction where we can cover a lot of bases, so let's talk about what if we want to do the same thing to each word in the list? Specifically, what if we want to print each word separately on its own line? Well, if I print wordies, you might try right off the bat. Well, okay, it's just printing the sort of the object version. It's still this list in the brackets and stuff, right? We want something a little cleaner. So, how do you do the same thing over and over on a bunch of things in a collection? Well, that's loops. So, loops are a way of taking a whole bunch of stuff, say these nice clean list objects that Python provides, and you're going to run the same code on all of them. So just go and do them all at once. So Python focuses on this structure called a for loop. And in particular, it uses this nice for each kind of idea. You don't need to fuss with that. But you'll see it in action in a moment. So what you're saying is, hey computer, for each thing in this list, do some set of code, right? So let's just do one and show you what I mean. The basic structure is, the first line is for some variable name that you're defining right now just for the space of the loop, in a list, do the following. Now, I have a little note here. In Python, indentation matters greatly. It is fundamental. So, whenever you open a statement like this that's going to have sub-statements, sub-instructions under it, you must indent. So you have to indent what you want done during that loop. So the point of the indentation is it helps to group the code. And for your own human eye's sake, I swear to you, it will make your life better if you learn to do this, not just in Python where it's enforced, but in every programming language. Always indent your code. Be careful with your white space. It'll help you. Oh my God, in the future you will be so happy about past you not being a jerk. So, but here are the two rules. The indented code has to be further in than its parent, so further in than the for instruction in this case. And it has to be, they all have to be indented to the same amount. We don't need to worry about that, but if we wanted to print word twice, for example, they would have to both be indented the same amount. So, for word in wordies, what's this saying? This is saying for each word, in is just a keyword that the language understands, in this other list, in this set of values. For each thing that I've named in the set of values, print it. Print that thing. I named it word. I could name it anything. In fact, over here, we'll name it something else. For boop in wordies. Now, interesting. We've opened up this statement that we know needs to be defined in multiple lines. So the interpreter is like, okay, I won't finish, but what do you need next? Now we have to indent. So I always do a couple just for vision's sake. We're going to print boop, right? Because boop is a variable that we just defined for this loop. We're saying for boop in wordies, print boop. What's that going to do you think? What is going to happen when I hit enter? Provided it didn't make an error and I blow it up. It's going to go and it's going to pull out each one of these words one at a time and slot them into the variable boop. And then what I say is, hey, you slotted that in there, print it. Print statements automatically go to new lines. So you do another enter just to make sure you're done typing. Bang, it executes. What do we have? The quick brown fox jumped over the lazy dog. All words on their own lines. Now, printing things on new lines that's a very simple case. But I promise you, being able to do individual processes like, say, printing or looking up the semantics or the syntactic structure of a particular word or syntactic category of a particular word, that's powerful. Being able to split this up and run over it in over and over is powerful. This is good. This is a loop. So, keep this indentation thing in mind, but this is cool. So we see this pair of lines, just 2 lines that we wrote, told the computer, hey, go take this pile of words and for each one, do something, print it. And you only had to write 2 lines. You didn't have to say, print the first one, print the second one, print the third one, right? This is huge. I've told you about a few fundamentals so far. This is another fundamental of programming. It's very important to be able to say, I'm going to write this instruction 1 time and I can run it infinite times. I mean, not literally infinite. Your computer will still have to try to do it all, but 1 billion times, 1 trillion times. Just do it that many times. So this is big. Looping is big. Looping is key. So keep in mind that looping is an important piece of this puzzle. Okay, so Python is doing a lot of work for us here, though. Look how clean this is. In 6 literal human words, we have instructed it to do a bunch of printing stuff that would be kind of tedious to do on our own. That's because Python is kind of holding our hand, but for 90% of cases, this is enough. We can get a little more complex, though, using things we've already talked about. So let's say we want to do something like print me both the index and the number, so the index number of the word and the word itself, right? So we can do that. We've already seen how to get the index and how to use the index, and we can also use a new function called range to do this. So in the same form, let's go ahead and do another version of this. So what's the idea? For each index in the range of numbers between 0 and the length of our list. Okay, whoa, what am I talking about? Well, look, when you want to index into a list, remember 0 is the first value, and you're going to run all the way up to the length value of the list minus 1. But that's fine. That's what range does. In fact, I'll show you right now. In fact, I will put it range 0 to len wordies, right? We'll do that. So range 0 len wordies. Oh, it comes out as an iterable value. I wanted to print it. Who cares? Okay. So don't worry about it. Just know that this works. And so when we go to this for loop, this is actually the standard way to do a for loop inside of Python when you need access to the index. So let's do it. So between 0 and the length of our list, that's what the values of index are going to be. Starting at 0, do the code, move up to 1, do the code, move up to 2, do the code, right? So for index in range 0 to len wordies. Okay, we've started our loop. Hopefully I print it properly. So now what do we want? We want to print both the index and the actual word itself. Well, before, if you recall, the word was just stored in Word, and that was nice and easy. This time we got to do a little work. So we'll go ahead and print, and this is where you'll see that print can actually take multiple values, index, and then we're going to print wordies. But remember, how do we get a particular word out of the list? In fact, how do I escape this? I'm just going to blow it up. Blah, 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 blah. Okay. So let's look at wordies again. Okay, there it is, right? We can see what's inside wordies. we're going to do our loop for index in range 0 up until the length of wordies. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. So that should be 8 or 9 values because 0 through 8. What are we going to do? We're going to print first the index number, which is stored in the index value, the variable index inside this loop. And then we're also going to use the index to go get the actual word. Because remember, you can index in there using wordies sub index. So this is our loop. What do we think is going to happen? Well, there it is. So it has printed the index number, which is the thing we're actually looping over, but we're still using that number to go grab the word that we want out of our wordies pile, our list of wordies. So, neat. You can see how you might construct for loops a little differently based on what you're trying to do, but essentially it allows us this incredible power to write code once and do it a trillion times. This is key to programming. Next, what if we want to do some differentiation? What if we don't want to do the exact same thing on all of our code, on all of our words, for example? We want to detect something about the words and then use that information to change the behavior of our program. This is where we get into the concept of branching. So you may have seen these before, if statements. So this is the idea you can have some instructions that are only going to happen when a certain condition is met. So what are conditions? Well, this takes us back to the Boolean idea. True or false, right? Something can be true, something can be false. And the most basic way to do it is with comparisons on numerical things, right? So we can do a bunch of equality checks. So is 1 equal to 1? A double equal sign means sort of a conditional thing, not the assignment value, right? Double equals means, hey, is this true? Are these two things the same? 1 equal 1 is true. What about 1 equal 0? Well, that's false. Okay, good. What about 10 equals 50? No, but 10 equals 10? Yes. All right. We can also do not equal, which will be the opposite. 1 does not equal 1. Well, that's false, because 1 does equal 1. 1 does not equal 0. That's going to be true. Okay. We can keep skipping. We can also do comparison of value greater than and less than type stuff. So, and also greater than, equal, etc. So let's do 10 is less than 50. That's true. 10 is greater than 50. Well, that's false. We know that. 10 is less than 10. That's false, because 10 is equal to 10. It is not less than 10. So 10, if we want to have a condition that includes everything below 10 and 10 itself, you can do less than or equal to. Just like you can do greater than or equal to. 10 is greater than or equal to 10 as well. That's also true, right? So that's the idea of conditions. And now we can wrap them into an if statement. Ooh, another kind of statement. Okay. So num1 is 10, let's say. The value 10 is now in num1. I want a conditional statement that's only going to print that if it's less than 50. So if num1 is less than 50, again, this is the format we use when we're opening up a block of code. We say if num1 less than 50, so this is the condition we're checking. If that's the case, then we'll go ahead and print this little string lower than 50. Is this going to happen? Is num1 less than 50? Num1 contains 10. Yes, this is going to happen. Lower than 50. Okay. Now what if we change num1 to 100 and do the same thing? And I'll even go up and just cheat a little bit because I'm tired of typing. If I do it this time, num1's value has changed. The code hasn't changed at all, but the data in num1 has changed. So now what should happen? Nothing. Yes, because we don't have an else situation. This is just, if this is true, do this thing. Otherwise, skip me. Don't do me. I am not code that you want to execute based on the conditions you've set. So now, that's good. The statement failed, that's good. That's exactly what it should have done. Now let's do one where we have a catch case. So if, I'll cheat a little bit again. If num1 is less than 50, print that, but else, a secondary case that says, okay, if the thing that happened up there isn't true, otherwise do this. Print higher than 50. So now when I do this, what's in num1? 100. So which thing should get printed? Higher than 50. So it's done something different based on the contents of the value. This is huge. Again, this is huge. Branching, this idea of branching, allows code to make decisions in a sense. It's able to now walk through some kind of values it's getting and do something different based on what's going on in the data it's working with. Again, there is no way to understate how powerful that is. And if you understand branching and loops, you understand a lot of programming. I promise you. Everything gets more fancy and elaborate the further you go out, but those fundamental ideas are in almost every language to some extent. Sometimes it's more emphasized, sometimes it's less, but the point is that this is the core of why computers is so powerful lately. So, let's put it all together. Recapping everything we've done so far here, loops and branching. Cool. So, let's combine them, right? Combine these ideas. And we're going to write a loop that's going to conditionally, for the first 5 words, print them in uppercase. For the rest, print them in lowercase. Okay, so we'll need the indexes to be able to do this because we need to compare the numerical position of the words to the value we've set, right? 5. Okay, so let's do it. For all the index values, so we'll do our for again, for each index in range 0 to len wordies, right? Our buddy. Okay. What are we going to do? If the index is less than 5, so 0, 1, 2, 3, or 4, if index less than 5, what are we going to print? Well, we're going to print, we got to go get the word, so wordies, so index dot upper, right? Because the word we are pulling out using the index is a string, so we can use its upper method to make it big. Hang on, trying to do it. Okay, so that's the if we're on the first 5 words scenario. Otherwise, else, what do we do? We're going to do the same print, but we're going to do it in lowercase. So print wordies index lower. Okay, there's a lot going on here, but it's all things that we've talked about already, right? So let's recap it before. Oh, I know you're itching. Before we actually hit enter, let's look and make sure we know what it's doing. So for this variable is defined for the for loop. It's called index, and it's going to contain each in turn the values 0 through, I believe, 8, because there are 8 words in this list, right? So then if index is less than 5, so if we are in the values 0, 1, 2, 3, or 4 for the index of the word, we'll do this thing, otherwise we'll do this other thing. Which 2 things are we doing? Print, okay, cool, we're going to print a word. We got to get the word itself, so wordies is the value, is the sort of the list of words we're pulling from, and index is which one we want. So we go get the one we want out of the list, and then we convert it to uppercase in the first case, and we convert it to lowercase in the second case. Okay, I've teased you long enough. Boom, the quick brown fox jumped. over the lazy dog. We did it. Now, what if we wanted to change it to... oh, annoying. This is where we would start... No, I've already ruined it. I was going to change it to 4 or 3 or something. Whatever, just enter. It's fine. So, that's the idea. I hope that this makes sense to you. I hope we've walked through the fundamentals in a way that is not totally intimidating. The idea is that this is the kind of stuff that you won't always be doing when you're working with text, right? You shouldn't always have to go through all these steps. In fact, a lot of these systems will take raw text and go ahead and convert them for you if you install a certain package in Python, right? It'll just give you give it the string, and then it'll go ahead and build its own crazy network of whatever it's doing. But it's important for you to grasp the fundamentals so that when you are using those things, you recognize the kinds of things that are happening inside. So we won't have an assignment attached to this one, but this is a walkthrough. Consider it kind of a lecture / demo, and I believe you should do this. You should do it one at a time. Do each one. This is going to be useful for you to when it comes time to do an assignment. It'll be useful to have done these things with your fingers. So again, go to this website. It opens a little terminal just for you to screw around in. A interpreter. Here we go. Blah, blah. Doesn't know what blah, blah means. And get used to playing with the interpreter. You know, you can branch out from what I've done here. You can do all kinds of stuff with these fundamentals. There's, it gets pretty complex down here. We've kind of crowned it all together, but it's useful. It's a good set of skills. So play around with it. Go for it. Consult this video if you want more tips. Again, you can always talk to me. And yeah, that's it. Thanks so much, and take care. I will post this up as the sort of lecture notes for the day. All right, take care.